Morning, everyone. Let us look on searching and sorting as it relates to Module 1 for Unit 2 Computer Science. All right, let me zoom in on this document. Okay, so searching and sorting. Searching and sorting is just as you would know of. Searching is where it is that you are finding the location of an item, but we're looking as it relates to structures that are being used to store data. So searching here, as it says, is the process of locating a particular element present in a given set of elements. So you can think about arrays and as an example, a stack, a queue, a linked list, whatever it may be, you are searching for a particular element. The elements can be numbers, the elements can be words, the element can be a letter, right? Whether it is a letter at the beginning, a letter at the end of a word. Think of you sometimes utilizing your computer. You want to find the name of something, but you don't necessarily remember what the name of it is. You're going to type in that part which you remember. Like another example would be like a song. You're using the internet. There's this part of the song that you know, but you don't know who is the artist. You don't know the name of the song. So basically, what you do, you wing it based on what you remember. So you search by that. So that's the process of searching. Sorting now, as you would know, would be the whole process of arranging, whether it is that you're going to arrange in order of in alphabetical order, which would be ascending A to Z, Z to A, whether it is that you're going to sort from largest to smallest, largest to smallest, smallest to largest, whatever it may be, is putting items in order. So here we have an example. It says Jenny is a teacher at an elementary school. And she needs to find all the students with names starting with J. So basically what she's going to do is enter J into whatever it is that she has. It could be a database, it could be a spreadsheet, it could be a Word document, whatever it may be. She's going to enter J. After it is that she entered J, she found that of the 5 students, only two students had names beginning with J. So she found Justin and she found Jessica. So the system now will output those 2 names. All right. Here we're seeing the input line is J, which is a character, and we're getting a string as the output, which would be Justin and Jessica. So here now we're looking on, or we're recalling, sorry. All right. So searching is locating information in a table or file by reference to a special field for each record, and this is called a key. The goal is to search to discover if any record matches that which you are looking for. So you're going to search the field, you're going to search of likeness, That is what it means in terms of field. So if you have a field which will have last name, first name, whichever one you're going to search by, it's not going to search everything. So is it that you're searching last name? Is it that you're searching age? Is it that you're searching first name? Right, that's that part. So when you were looking on C programming for Unit 1, you should have come across this particular syntax, which is strcmp, which is string copy. So what we are going to identify is that once it is that you're using C, normally what you would use is the string copy to search through your files to return that which you are looking for. Is it that the chat is not open? The chat is open. Hold on. The chat is open. Okay. So if you have any questions, kindly place those in the chat. Let me test it. Oh, it's working for me. All right, good. All right, so let's look on linear search. This is a type of searching technique. So linear search now is a sequential search. Knowing sequential, it means that you are going to visit each element or each section. It's a method of finding a target value within a list. Of the different searching techniques that we're going to look on, this one is possibly the shortest, which means that it's going to identify your data the fastest. The principle of linear search is that it sequentially checks for each element of the list for the target value until a match is found. This one, looking on the algorithm here, we have two elements. So we have array A and we have value X. Array A would be the field that you are searching. Value X is what you are looking for. So the first thing you're going to do, once it is that you're writing the algorithm for this, for linear search, you're going to set your counter to 1. And we have I right here, but if you have a different variable, you can set that. Then we have if I is greater than n, then go to step 7. So we're going to skip out step 3. 1 minute. Find that this is not moving as how I want it to. Then now it says you will go to step 7. Step 7 is to print the element not found. However, if AI, right, is equal to X, so if in array A, right, I is equal to element X that we're searching for, then we should go to step 6. Step 6 says print element X found and where it is found. And then it would go to step 2, and step 2 is where it's going to continuously check. So it's in a loop, right? And then it would exit depending on what is done. So this is how the pseudocode would look. We have the list, which is the array. We have the value that we are looking for. This is using modularity, so it's showing you a little function right here. So you'd have enter and return. The loop structure, so for item in the list, what the item in the list you are looking for, if match item equal value, right? So if they search the array in the match item and find the value you're looking for, then it should return its location. Is it in location 0? Is it in location 4? Is it in location 1? Then you would end your if, end your for. This if can have an else statement where it is that you can say match not found at the end. Whichever one you decide, that is fine. So let's look on linear search. So here we have an array, right? This array is storing integer values. The top part, which is your index right here, this is showing the location of the different values. Good. So here we have the data that is stored in each location. So in location 8, we have 36. In location 4, we have 19. And in location 14, we have 80. Here it is saying that we are looking for 28. So as I said, it uses sequential, which means that it is going to each location. So it's going to visit location 0, 1, 2, 3, 4, 5, 6, 7. It's like a cassette tape. If you have 10 songs on the tape, you will have to, if you want to listen to song number 10, it means that you will have to visit all 9 previous songs before reaching to 10. It's not like a CD where you can skip, 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 skip until you reach track 10 and then you listen to track number 10. All right. Good. All right, so let's see how this works now. All right, so we're looking for 28, as I said, and we have identified before that 28 is in number 7. Now, once it is that it identifies the number, it's just going to stop. So here, it's going to go to location 0, and then location 0, we have value number 1. A comparison would be made. Is location what? Oh, why don't I have a pen for this? Okay. It's going to check now. Is location, which is the name of the array, the name of the array is data. Is data index 0, right, equal to the value that you're looking for, which 28. We're seeing here that 1 is not equal to 28. So it's going to print false or value not found. Then it's going to check number 1. 5 is there. Then it's going to write. So the structure would look like this. Let me change the color so we can see clearly. The name of our array is data, right? And we're going to put the index that we are looking for. So we're starting at index 0, right? Is index 0 equal to the value that you're looking for? And let's say you use a variable x, right? That is what it's going to continue doing. And this will be in a loop until data and the index will be a variable as well. So C is my counter right here, which is value, which is location, sorry. So data, which is value, C, which is location. So it's going to continue checking to see if that is equal to X, which is 28, which is what we're looking for. Once it is that that value is found, it will output true. And once it outputs true, then what happens? The search will stop because we have found that which we are looking for. Any questions on the linear search? Hi, Jose. Did you catch that part? Any questions on the linear search? It's pretty straightforward. Normally, you'd get questions saying that you should complete a linear search or any other searches. It will tell you that you need to complete a search and you should show the full step. So if you're going to show the steps, then this is what you would do. All right. All right, moving on. All right, so the next one is what we call a binary search. So binary search is the fastest searching method. So I stand corrected. So this is the fastest searching method with runtime complexity of O log n. This is calculations that later on you will, if you continue into computer science, that you become very familiar with. The search algorithm in principle of divide and conquer. So we are going to divide into search the first half. If we don't find the search first in the first half, then we divide the second half in two. If we don't find in the second half, then we move to the third half, and it makes it much easier for searching to take place. So binary search looks for items by comparing the middlemost item in the collection. So there's a calculation that we're going to do once it is that you are using the binary search. After it is that is done, it is going to find the middle, compare the value that you're looking for to see if it matches. Now, how binary search works is that your array must be sorted. If it is not sorted, the divide and conquer method will not work, right? So your array must be sorted first and foremost for the binary search to work. Example here, we're looking for 31. We have array and we have 10 elements in this array called data. These are the data, that's what we're going to call it. The data, we have 10 values, which means that we have 10 locations starting from 0 to 9. So when it is that you are carrying out the binary search, you are going to take the first location identifier. In this case, it is 0. And the last location identifier, oops, hold on, let me see if I can use fill instead. All right, good. I think that is better than this one because it makes it dark. And then fill it instead. Good. So we take the first location identifier and the last location identifier, which is what we have here, and we're trying to identify the middle. Yes, it is that you can look at it and you can identify the middle, but if the question says show working, you have to show the full step. So first location, which is 0, last location, which is 9. To find the middle, you're going to add these two together, divide it by 2 to find the middle. Now, if it is that you get a decimal value, do not round up. We take the whole value that is given, and that will be the middle. In this case, what you're seeing is that the middle is 4. We didn't round up to 5 to make it 5. The middle is 4, right? So we are looking for 31. Remember I said before that your array must be sorted. So if it is that in location 4, there's 27, right? It means that from 0 to 4, the location 0 to 4 does not hold the data you're looking for. So we scratch that section or we scratch that half. Good. We don't need to look over there because we know based on our calculation that the information cannot be found this side. All right, we know it not over here. So we're not paying 0 to 4 any mind. Then we repeat the process now. We have eliminated 1 to 4. So or to find the middle now, we are going to identify the starting value, which is 5, the ending value, which is 9. Add those two together, you're going to get 14. 14 divided by 2 to find the middle would be 7, right? So we're now looking on location 7 because we have divided this array again in 2. Good. So we have this part. So in location 35, right? Remember we're looking for 31. Right, we're looking for 31. So in location 7, we have 35. Now we're going to compare. Is 35 equal to, greater than, or less than the value that we are looking for? Because it is greater than the value that we are looking for and the array is sorted, we can now eliminate everything to the right. So we know that our data is not over there because we're looking for 31 and 31 is less than 35. So location 79 would not have our data. Now looking on this now, we're going to do the same method again, which is 5 plus 6. Starting value, ending value. 5 plus 6 is 11. 11 divided by 2, that is going to give you 5.5, right? So we are here now, which is at location 5, right? Which means that we're going to compare this value. So we're going to compare, is the value in location 5 equal to that which we're looking for, which is 31? Yes, it is. So it means now that 33 in location 6 is now out because we have found our data. Any questions here? Any questions here? No? All right. So we will be moving. So that was the binary search. And as we said before, binary search uses divide and conquer, right? This was just an explanation of that which we just did. All right, so let's look on the pseudocode now. Pseudocode for binary search. So first thing, A, sorted array, that's the name of our array. N is the size of the array, and X is the value that we're looking for. We were looking for 31, right? So A would be the name of the array, N would be the size of the array, which was 10. X is the value that we were looking for, which was 31. It says set upper bound to 1 and set lower bound to 1, upper bound to n. N is the size of the array, right? Remember that we said the size of the array is 10. So if the lower bound is 1, 1 to 10, 10 values. So while X is not found, right? So while X is the value that we're looking for. So while X is not equal to array N, no, right? Then if upper bound is, once it is that, it is not, so we're going to do the if statement. If upper bound, which is N, which is 10, is less than lower bound, which is 1, exit does not exist, which means that you have searched everything and you don't find the value, right? Otherwise, what we're going to do is that we're going to calculate midpoint, and we did that part just now. Midpoint equal the lower bound, which is 1, plus the upper bound, which is 10, divided by 2, which would give you 5. Now, what I recommend is that because your array is going to start at 0, you can set your lower bound to 0, which is fine. It's just that you would have to work out to say that, all right, then my upper bound is going to be 9 if you start at 0. No, it would still be 10. Never mind. Leave that part. All right. So what should happen now after we calculate the mid bound? So here, if A, which is the name of the array, mid bound is less than X, set lower bound equal midpoint. So what we're going to do, we are reassigning, just as we did before with plus 0. 0 and 9 would have been equal to 9. 9 divided by 2, 4.5. At that point, our middle bound was 4. We didn't find the data there, all right? So mid bound is going to be equal to 5 because we have eliminated 0 to 4, right? So midpoint was 4. Lower bound is now going to increase, which is the lowest value, which is the starting value now, which would be midpoint, which is now, which was 4. 4 plus 1 is 5. And we move on to location 5. Now, if a midpoint, because we're going to go back to calculation, is greater than x, then you're going to change the upper bound, right? So upper bound would be equal to midpoint minus 1. So here we had 5. 5 minus 1 would have been 4. Once it is that you find that this is an example of an algorithm, however, you may write your algorithm different, and that's completely fine. Once it is that you incorporate your loop, once it is that you incorporate the if statement, which is going to change the values, then your algorithm will be given the necessary marks, right? Like in this case, it would make sense for you to calculate the midpoint outside of the loop. That calculation must be done within the loop itself. Otherwise, midpoint would be a constant value. All right, now we're on to bubble sort. What is bubble sort? So the first two were searches. Now it is that we are sorting. So we looked at binary search and we looked at linear search. The bubble sort. Bubble sort, it is going to take some time, especially when you have an array that has a large volume of data. Hence, it is not necessarily recommended for bubble sort, right? Now, bubble sort is the simple sorting of an algorithm. This sorting, why am I going back? Oh, sorry. Oh, right here. Right, so bubble sorting is a simple sorting algorithm. This sorting algorithm is a comparison-based algorithm in which each pair of adjacent elements is compared and the elements is swapped if they are not in the order. This algorithm is not suitable, as I would have said, for large data sets. So let's look on this example now. This is our array. This array has 5 elements. 5 elements, 37, 23, 34, 3, and 15. Looking on this, you can clearly see that it is not organized. It is not arranged, and we're going to arrange it in ascending order, which is from smallest to largest. So what you're going to do is that you are going to compare the first 2 values until they are in the right place. All right. So note now, we have 37 and 23. Good. In the first step, we compared 37. We're going to compare 37 and we're going to compare 23. Clearly, location 0 is greater than location 1. So we're going to swap it, right? And once you're swapping, normally you will have a temp location that you're going to put in and make the necessary swap. So we're going to put 23 in location 0 and 37 in location 1. And that is what you're seeing here at step 1. 23, 37, 34, 3, and 15. So 23 is now at the beginning. So because we have compared location 1, 0, and 1, what we're going to do now is to compare location 1 and 2. That's these two. Right. So now what we're seeing here is that 37 is greater than 34. So it means that location 1 is greater than location 2. So we now need to swap. And that is what you're seeing here. So by the end of step 1, this value, which is at location 1, which was greater than, is supposed to be in its rightful place. That's the aim for step 1, right? So we're now going to swap 37 and 34. Good. So when we swapped 37 and 34, the algorithm is now 23, 34, 37, 3, 15. So we compare location 0 and 1, location 1 and 2. Now we're going to move on to location 2 and 3. Right. So again, we're seeing that location 2 is greater than location 3, which means that we need to make a swap, right? And that is why here it is written like this. So we have 23, 34, 3, 37, and 15. What are we going to compare now? We're going to compare location 3 and 4. So we're going to compare 37 and 15. Clearly, location 37 is greater. So what we're going to do, we're going to make a swap, and we're going to put 15 at location 3 and 37 at location 4. Now, based on pass number 1, you can clearly see that this is going to be time consuming, right? Good. Let's move on to step 2 now. Step 2 is where you start the whole process over again. 37 is in its rightful place. Good. That one is locked, right? So let me change this. Everyone in red is locked into its rightful place. Good. So now it's 23 and 3. So we're starting again, right? 23 and 34. When we compared 23 and 34, location 0 is less than location 1. So we leave that be. Good. No changes made there. Then now we're going to compare location 1 and 2, right? When we compared location 1 and 2, we realized that location 1 is greater than. So we're going to make the swap, right? So we have 3, 34, 15, and 37. Remember again, 37 is locked. Good. So what are we going to compare now? We are going to compare 34 and 15. All right. 34 and 15. Again, this one is greater. Location 2 is greater than. So we are going to make the swap. So right here at the end of pass number 2, there are 2 values that are locked in their correct location, which is 37 and 14. Moving on to pass number 3. Pass number 3 now, what we're going to do, we're going to compare again location 0 and location 1. So 23 is greater than 3, so we make the swap right there. These two we're comparing. Right. So we make the swap. So now we have 3, 23. So from this step, which is step number 3, 23 should be in its rightful place. Good. So now we're going to compare location 1 and 2, which is 23 and 15. Right. 23 is greater than 15, so we are going to make that swap. Right? So now we have 3, 15, 33. Oh, hold on, let me see if I can send this down instead so that we don't have. So remember, the aim was to put 23 in its rightful place. Good. So now we have, from that pass, these 3 would be locked in their location. So for this step now, what you would do is that if it was not in the correct order, right, you would compare location 0 and 1 again. And if it is that there are any changes, swap it, and that would be the final change, right? So that now is your bubble sort. As I said, time consuming. So that would be the drawback of your bubble sort. Any questions here? Hi, Amelia. All right, so let us look now on the algorithm. So it says we assume list is an array that is the name of the array, list is the name of the array, n, number of elements, so n is the size of the array, and further we assume swap, the swap function. And as I said, once you can use the swap function, or what you can use is a temp file, right? If you use temp where it is this doesn't have, right, let's go back up, let me show you what I was talking about. So for temp, you would have, we have, what's the name of the array again? Let me scroll back down. All right, so the array name is list, and we are at, and it says n elements. N elements, right? So basically, what you would do is that you would have the two locations. For you to swap it, you would need to take the data, which is in location 2 at the time, put it in a temp file. Then now put location 3 in location 2, and then put the data that is in your temp file in location 3. That's how you would do it if you're not using the swap function. All right, so let's look on the algorithm here. So we're using modularity. So begin bubble sort, right? And list. So bubble sort, I think it is a function name in C. And the list would be the array name. So for all elements of list, so you're checking list and the size of the list. If list location I is greater than location I plus 1, so 0 plus 1, then you should swap it, where it is that you're going to interchange based on what we would have done here. And if N4, what you're going to return is the sorted list, and then you would have your end. Pretty straightforward. As I said, your algorithm does not necessarily need to look like my algorithm. So now we are at simple selection sort. Is there any question on the bubble? All right. All right, so simple selection sort. So selection sort, that is a simple sorting algorithm. It much easier than the bubble sort to me. It compares the algorithm by dividing the list in two parts and sorting part to the left and then sorting it based on the other half. Let's look on that concept. So the principle of bubble sort, the smallest element is selected from the unsorted array, and oh, this should not be bubble sort. Should be selection. Right. So the smallest element is selected from the unsorted array and swapped with the leftmost element of the array and becomes the part of the sorted array. Now, if for the bubble sort, when we did the first round, notice that the rightmost element would have been sorted. So the highest value would be in its place. The selection sort is the opposite, where it is that the smallest element, which is the leftmost part, will be sorted first, right? So looking on this array again, we have 2, 4, 6, 8 elements. We have 8 elements, 8 data in this array, and it is clearly not sorted. So your system is going to do a search. 10 and 13, no, 10 and 13 is All right, 13 and 8, not the smallest. All right, 10 and 13, which is smallest? 10, right? Now we're going to compare. 10 and 8, is that the smallest? No, smallest is going to be 8. 8, so 8 would be in location 1. It's not going to move, it's just going to assign it to be smallest. Then 8 and 15, 8 is still the smallest. 8 and 16, 8 is still the smallest. 6 and 16, 6 is now smallest. Sorry. Then now it's going to compare 6 and 22, 6 is still smallest. 4 and 6, 4 is now smallest. So all right, we're now going to switch places. So 4 is going to go to the beginning and 10 is going to go to the end. Right? So now 4 is in its rightful place because we have made that comparison. For step 2 now is to identify the second smallest, right? So we're going to compare again from location 1 to last. So 13 and 8, right? Which would be smallest? 8 is smallest, and this is pretty fast. So 8 is smallest. 8 and 15, 8 remain the smallest, right? 15 and 16, 8 still remain the smallest. 6 and 8, 6 is smallest. 22 and 6, 6 is still smallest. And 6 and 10, right? So we have identified that now 6 is smallest. So we are going to swap the location with those two. So if you notice now, 6 is in this place, and where 6 was, 13 is now there. So these two are now sorted. So continuing now for step 3, first two locations are okay. Now we're going to move on to third location to ensure that it is okay. So smallest is now equal to 8. It's going to compare these two locations. All right, still smallest. This and this one, 8 is still smallest. 8 and 13, 8 is still smallest. 8 and 22, 8 is still smallest. 8 and 15, 8 is still smallest. So 8 will remain in its place. All right, so these are now clear. So now we're going to check for 10, right? Checking now, we're seeing 10 is okay, right? So 10 and 16 was compared, realize that 10 is the smallest. 10 and 13 compared, 22 and 10 compared, 15 and 10 compared. So 10 is in its rightful place. So there would be no changes there. Now, smallest is 16. 16 compared with 13, 13 is smallest. 13 compared with 22, 13 is still smallest. 13 compared with 15, 13 is still smallest. So we're going to swap 16 and 13 since that's the case. So now for step 4, these locations have been sorted. All right, so now 16 is smallest, right? 16 and 22, 16 remains the smallest figure. 16 is then compared with 15. 15 is smaller, so we're going to swap positions with 16 and 15. So these locations have been sorted. Good. Now we have two values, right? So 22 is going to be smallest currently. Compared 16 and 22, then we're going to make the switch. And at step number 6, all the items in your array will be sorted. So for the selection sort, it is faster than the bubble sort, right? For the bubble sort, at the end of the first step or the first sort, the last value, which is the largest value, will be in its place. For the selection sort, the smallest value will be in its place. Please ensure that you know how to differentiate between them. What are the drawbacks in terms of which will be faster, which would be slower? We looked at 2 searching techniques and 2 sorting techniques. So for the algorithm now, we have procedure selection sort. That's the name of it that we give. Very much different from the C code. So it says list the array items, right? So you're going to give the array items in the curly brackets. So you have 5, 10, 16, 45, 67 as example, right? N would be represent the size of the array. So for my array here, it's 2, 4, 5. So the size of the array would be 5. For I equal I to n, which is 5 minus 1. Why minus 1? Because the location of the array is always starts at 0. So when I give it size 5, the system needs to know that it should stop at location 4 because I start at 0. So 0, 1, 2, 3, 4, 5 locations. All right. Then min equal I. So we're setting the minimum value to be I, which is the first location, which is what we did. All right. Then now it's for j equal I plus 1 to n. So we're going to continue now within this loop, and it's going to continue comparing. So if list j is greater than list min, then min equal j. So it will continue comparing all the values in your array to identify the minimum value. Once the minimum value is found, then the values are swapped. And that is the swap function that we have below. And this will continue until all values have been sorted. So for module 1, you'll find that is the shortest module. So it looks on selection sort. It looks on the searching and sorting techniques. It looks on stack, which ADTs, which is stacks, queues, and linked lists. How it is that you write the algorithm for those, how it is that you write the C code for those, what are the principles for the ADTs, right? And we know that for stack, it uses last in first out. For queue, it uses first in first out. So you need to know these techniques that it uses, the codes that are used for it, and then you will be clear for module 1. In our next session, we will be looking on operating systems. I want to do 3 sessions for operating systems and networking. So I want to do a next session online. I will ensure that I get you that information ahead of time. You can look out for the paper 2 for last year. The solution for that on the page shortly. Hopefully you guys will watch and support that. All right, so we have come to the end of this live. Is who name your average Jamaican? This look like I think this is Tajmar. Tajmar always have some weird names online. Oh, Popsy Dopsy. Oh, sorry. Sorting and searching is pretty easy, you guys don't need to worry about that part. You guys don't need to worry much about that part. The bulk of the notes is in module 2 and module 3. Hi, Jackson. So is who Popsy Dopsy? I don't know. Which name is that? Jaja. We need to find out who is Popsy Dopsy. And it's a YouTube channel too, so I can go on it and find out later on. Right. So where the bulk of the notes is for module 2 and 3. 45 multiple choice, yes. Which will come from all 3 modules. So you have paper 2, 45 multiple choice. Oh, Your average Jamaican is Justin then. I'm going to go with Justin for your average Jamaican. I hope you guys are studying or have started. Ah, Jackson, I got it right. All right then. Yes, man. Thank you, Jackson. I hope you guys start studying, please. Please and thank you in the name of everybody. Ensure that you put in the work and start the studying, especially when I know that more time will be, invested in my subject after physics, and physics is is the fourth or the second of me. Yeah, one of those days, right? So I was right. All right, your average Jamaican. All right. Yes. All right, guys. So that's it for today. I just wanted to look on the searching and sorting. No, no, you're going to do well for physics. There's power in our words, and we are going to declare greatness for all subjects being done, right? This year was a trying year, and we shall all succeed and do well. All right. Thank you, Amelia. And it's a channel. I don't have channels. Yes. Yes, Jackson. And you can always refer to this video for explanation. Or watch the video again and again and again until it becomes a part of your. Let me know why. All right, then. All right, later, guys. Remember to give the video a like. Please like before you leave. Like the video before you leave. Give it a thumbs up. Like before you leave. And after you like, you may go. Yes. Later, Popsy Dopsy. Like the video. Like the video. Ah, all right. Please, Popsy Dopsy. I need to do a giveaway on this channel, Anybody have any ideas? Mwah. Love you too, Justin. All right.